We've been looking at different types of equations. Yesterday at the end of class, we were looking at different types of equations that we could use substitution to manipulate it to look like a quadratic equation to solve. So you have an example in front of you, 3x raised to the negative 2 power minus 7x raised to the negative 1 power minus 6 equals 0. So there's different ways that we can approach solving this. I could rewrite this equation with no negative exponents and then solve it that way by clearing my fractions. But I'm going to use the substitution method that we were using yesterday. In order to use that substitution method, you need to remember that if we had some base raised to a power, so for instance, recall, if we had b raised to the n power, and then that was all raised to the m power, then the rule is multiplication. So power to power, we multiply our exponent. So this is the same thing as b to the n times m power. So I'm going to use that to manipulate this to look like a quadratic. I notice that I can let u, so let u, equal x raised to the negative 1 power. So let's first just kind of rewrite this x to the negative 2 power to be 3. This is the same thing as x to the negative 1 power. And then that is quantity squared minus 7 x to the negative 1 power minus 6 equals 0. So we had chosen u to be x to the negative 1 power. We're going to go back in here and substitute in u wherever we see x to the negative 1 power. And so doing so, we get 3u squared minus 7u minus 6 equals 0. So we manipulated this to look like a quadratic, so you can use one of the methods we've used to solve quadratics. You can try to factor this, you can use the quadratic formula, complete the square method. I am going to try to factor this. I notice my value in front of my squared term is not 1, and so I need to do my AC method and do trial and error through that. So my AC method, so a times c, my a value, my coefficient in front of the square is 3, times my constant, which is negative 6. So I'm looking for two numbers that multiply to that multiple, which is negative 18, but would sum to be my middle term of negative 7. So I notice there are two numbers that I can multiply to get negative 18 and add to get negative 7. And those two numbers that would work would be negative 9 and positive 2. So once we figured out those two numbers, the next step was to rewrite our middle term using those numbers. And so rewriting this, we have 3u squared. So instead of negative 7u, I'm going to rewrite that as negative 9u plus 2u. And then bring down our minus 6 equals 0. Once we rewrote the middle term using those two numbers we found, we did factoring by grouping. So we've grouped the first two terms together, and we grouped the last two terms together. And so factoring out what we have in common with 3u squared minus 9u, I notice they both have a 3 in common and a u in common. So I'm going to factor out a 3u from both of those terms. Doing so, we're left with u minus 3 from the first two terms. And then the last two terms, 2u minus 6, I notice they have a positive 2 in common. So I'm going to factor out. So I don't forget that plus 2, and then times. Well, factoring out a 2 from 2u minus 6 leaves us with exactly what we had in the other parentheses, u minus 3 equals 0. If those parentheses weren't the same, then we would go back and manipulate them to be the same. And so again, we're going to factor out what they have in common. Notice they both have the same parentheses, u minus 3 in those groupings. And so we can factor out the u minus 3. Factoring out the u minus 3, we would be left with 3u plus 2. This is all equal to 0. So we factored this. We're going to set each factor equal to 0, and we're going to solve for u. And once we've done that, we can go back and figure out what x has to be. And so looking at this, we have u minus 3 equals 0. And we have 3u plus 2 is equal to 0. So let me just pause for a sec. So u minus 3 equals 0. We get u is equal to 3. And then 3u plus 2 is equal to 0. Let's subtract 2 on both sides. We get 3u equals negative 2. And then divide by 3, we get u is equal to negative 2/3. We're not done because we wanted to figure out what x was, not u. So let me erase this and let's come over here and let's solve for our x value. So now that we have our values of u, let's figure out what x is. So we have 3 is equal to x to the negative 1 power, or x to the negative 1 power is equal to 3. Where's that at? And we had x to the negative 1 power is equal to negative 2/3. So a couple of things that we can do to solve this. I can rewrite that without a negative exponent. So x to the negative 1 is the same thing as 1 over x, and I can solve that way. Or I can use that fact above about exponents, power to powers multiplying. I want that x to the positive first power. And so actually I really know that I could raise, if I do something to one side, do it to the other, I could raise both sides to the negative 1 power. So that x to the negative 1 power raised to the negative 1 power just gives me x to the first power. So this is x is equal to 3 to the negative 1 power. Remember, negative exponent, make it positive. We can bring it down to the denominator. So we get x is equal to 1/3. Same sort of idea that we can do over in the other example, but let's just solve it the other way. Let's first rewrite x to the negative 1 power to have a positive exponent. So this is the same thing as 1 over x is equal to negative 2 over 3. So I notice I have an equation. I want to solve for x. X is in my denominator. But I also know that we can solve equations by multiplying through by the least common denominator to clear those fractions. So let's do that. Let's multiply both sides of this equation by our LCD, and our LCD is least common denominator is 3x. So if I multiply 3x to this side of the equation, I do it to the other side. Well, 3x times 1 over x, the x's cancel, and we're just left with the 3, is equal to, the 3's are going to cancel over here on the other side of our equation, and we're left with that negative 2 times 3. I'm sorry, negative 2 times x, which is negative 2x. Divide through by negative 2, we find that x is equal to negative 3/2. So we have two solutions to that equation. Okay, so the next question in front of us is 3x, the x is raised to the 4/3 power, plus 5x, that x is raised to the 2/3 power, minus 2 equals 0. So again, our goal is to manipulate this to look like a quadratic. Remember, power to power, we multiply. Usually, look to see if this middle piece can be manipulated. So I noticed that if I chose u to equal x to the 2/3 power, well, notice if I square that 2/3 power, power to power multiplying, this would give me x to the 4/6 power, which is that first term we have. So I can go back, manipulate this. I can rewrite this. This is the same thing as 3x raised to the 2/3 power, that 2/3 power quantity squared, plus 5 times x to the 2/3 power minus 2 is equal to 0. Going back and rewriting, wherever I see x to the 2/3, I'm going to replace that with a u. So we have 3u squared plus 5u minus 2 equals 0. So again, I notice that that coefficient, that number in front of my u squared, is not 1. So I need to go about and either try to factor, use the quadratic formula, whatever method you prefer. I'm going to factor using the AC method. So looking at my coefficient A, so the number in front of the u squared times my constant, -2c, gives me -6. So I'm looking for two numbers that multiply to give me this -6, but with sum to give me that middle term of 5. Multiplying, getting a negative, I know one's negative, one's positive. Summing to get a positive, I know the larger number without looking at signs has to be positive. So I know 6 and -1. 6 times -1 is -6. 6 plus -1 is 5. So we found those two numbers. We're going to rewrite our middle term using those. So rewriting this equation, we have 3u squared plus 6u minus 1u. I don't have to put the 1 in front of the u. Minus 2 equals 0. Now we want to factor by grouping. Noticing the first two terms, 3u squared plus 6u, they both have a 3u in common, so we can factor that out. Factoring out a 3u from both of those terms, we're left with u plus 2. I notice the last two terms, -u minus 2. It almost looks what I have in that side, that parentheses, but I need to factor out a -1. Normally I don't write the 1 there, but I am just to make it look like, help you see it visually better. So factoring out a -1, we would be left with quantity parentheses u minus 2 equals 0. We have this u plus 2 equals 0. We have the same factor of u plus 2 in common with both groupings. And so that all times 3u minus 1. And then this is equal to 0. So set each factor equal to 0 and solve. So u plus 2 equals 0 when u is -2. 3u minus 1 is equal to 0. Add 1 to both sides, we get 3u equals 1. Divide by 3, we get u is 1/3. So again, we're not quite done because that's what u is. We wanted to know what x is. So if we go back up here, I'm just going to erase my work in here. Give me some room. Okay, so if we replace u with what we found, I know we have -2 is equal to x to the 2/3 power. And I have 1/3 is equal to x to the 2/3 power. Okay, so I want to get rid of that 2/3 power. I want that exponent to be 1. I notice if I multiply 2/3 by the reciprocal, 3/2, I get back 1. So let's raise both sides of our equation by the reciprocal of 2/3, 3/2. So I get x is equal to this -2 all raised to the 3/2 power. Okay, so some more rules on exponents that you may or may not remember. Recall if you have a rational exponent, it could be rewritten as a radical or vice versa. So if we had, let's say, b, and that was raised to the m divided by n power, we can rewrite that. the denominator of that rational exponent is what root you're taking. So we're taking the nth root of b raised to the mth power, whatever that numerator is. So noticing that, let's rewrite what we have in here. So this is technically x is equal to, my denominator is a 2, so that's a square root. We don't usually put that index in there. -2 quantity cubed. Same thing for the other equation. We can rewrite this as x is equal to the square root of 1/3 quantity cubed. Okay, so I noticed that underneath the radical, -2 cubed. So -2 times -2 is +4. 4 times -2 is -8. So this is giving me a square root of a negative. And we had talked about yesterday, a square root of -1 is I. Technically, when you're simplifying radicals, we can break it down as multiple. Like I know there's a factor of 8 that's a perfect square, which is 4. Let's just write it like this, times -1 times 2. So this is the same thing as taking the square root of 4, which I can pull out of the radical, which is 2. Square root of -1, which is the imaginary number I, all times √2. Over here, let's cube our fraction 1/3. You can think of that as 1/3 times 1/3 times 1/3, or you can think about it as cubing the numerator, 1 times 1 times 1, which is 1, all over 3 cubed, cubing the denominator, which is 27. So a lot of times we like to pull out what we can. If you have a square root of a fraction, we can rewrite that as the square root of the numerator over the square root of the denominator. So I see that x, the square root of 1 is 1, all over. I notice there's things I can pull out here, because this is 27 is 3 times 9. 9 is a perfect square. And so I get x is equal to 1 over, well, square root of 9 is 3. So √3. I'm not going to leave it like that, just because a lot of times we don't like radicals in that denominator, and just to get used to getting rid of radicals in the denominator, which you'll be doing a lot, especially when you're in trig, we can rationalize that denominator. So you're basically thinking about what you can multiply, a fancy one. In my case, what can I multiply square root of 3 by to make it a perfect square underneath that radical? Well, in order to multiply underneath the radical, they both have to have a radical. So square root of 3 over square root of 3. So looking at that, simplifying, we would get x is equal to square root of 3, because 1 times square root of 3 is square root of 3, all over 3. Square root of 3 times square root of 3 is square root of 9, which is 3. So we get here that x is equal to √3, all divided by 9. Okay, so we have two solutions. Only one of them is real and one is a complex number. I'm just curious. And it might not, it doesn't have all the answers in here right now. I was just curious if they showed me how they wrote their solution, so I could have guided you better. Look at my lab and mastering. They will tell you, round to the nearest second decimal place, the hundredths, or rewrite it as a fraction. I know we have a hard time sometimes reading things. We see that it's wrong and we want to go back, and so when my math lab or my lab and mastering says, I'm sorry, but read it, because it might be actually the correct answer, but just in the wrong form. Okay. So you might have the right process, but just didn't write it in the right form that they wanted it. Another thing, just because we're talking about MyLab and Mastering real quick, if you are ever working through MyLab and Mastering and you find that maybe your answer is right, but you wrote it in the wrong form, like maybe it wanted the equation y equals x plus 2, and they already had the y value there, you just had to put the x plus 2 there. So basically you had it right, you just ended up putting that variable y in there. You don't have to technically go back and redo that whole question. If at the end of the section, maybe keep note of which ones you want me to go back and look at, you can shoot me an email, say, hey, will you look at number 1.2, number 5 and 6? I got them right, but I just wrote them in the wrong form. I'll look at it, see that you did have it right. If not, I'll let you know what you did wrong, and I'd go back and give you some credit or all the credit for it. So just to be aware of that while you're working through the homework. Any questions on the one that we just did up there? Let's throw up something else. So it's definitely, this type of question could be on an exam. And here's one that looks good because it gives a lot of different methods that we've done. So you have the fourth root here of 4 minus 3x squared. And this is equal to x. The directions, well, this has mixed practice. Find the real solutions, if any, of the equation. That last problem did say find the real solutions of each equation, so we would have excluded that imaginary number as a solution when we typed it into MyLab and Mastering. Turn on the video again. Start. So the next question in front of us, we have the fourth root. Underneath that fourth root, we have 4 minus 3x squared. After that fourth root, we have the equal sign and then x. So we want to solve this. We want to solve for all real solutions. So I notice we have a radical in the equation. We talked about solving equations with radicals yesterday. We isolate the radical on one side, which this one is, and then we're going to raise both sides of our equation by the index. So we're taking the fourth root of this, so we're going to want to raise both sides of this equation by the fourth power so that we can get rid of that radical. So doing so, the fourth root quantity raised to the fourth power, the radical disappears, and we're left with what's underneath the radical called the radicand. We're left with 4 minus 3x squared is equal to x to the fourth power. So looking at this, I notice it could be manipulated to look like a quadratic. I notice I want to get everything to one side of my equation. I could subtract x to the fourth on both sides, but then my number in front of that x to the fourth power is not positive 1. So let's add 3x squared to both sides and subtract 4 to make that equation equal to 0. So we would have x to the fourth adding 3x squared, so plus 3x squared, subtracting 4, so minus 4, and now this whole equation is equal to 0. I see that this can be manipulated to look like a quadratic by choosing u to be the variable in that middle term that we wrote, which is x squared. Technically, I know x squared, quantity squared, power to powers multiplication is 4. So that would give me that first term plus 3x squared minus 4 equals 0. Rewriting this, wherever we see an x squared, replacing it with u, we have u squared plus 3u minus 4 equals 0. I'm happy that coefficient in front of the square is 1, so I don't have to worry about using the AC method. You can, but it's overkill. All I need to find are those two numbers to multiply to -4, add to +3. And I know +4 and -1 would do that, so I can factor this as u plus 4, u minus 1 is equal to 0. I can easily solve u plus 4 is 0 when u is -4. U minus 1 is 0 when u is 1. I want to solve for x, though, not u, so I'm going to rewrite two equations, replacing u with the numbers I found. So I either have, let's just write it this way, x squared equals -4, or I have x squared is equal to 1. I noticed, well, I could use the square root method here, or I could bring everything to one side of the equation and factor. Let's use the square root method, much faster, much easier in this case. The squares are already isolated. Take the square root. Don't forget the plus or minus in front of the one radical, or you're missing one of the answers. So square root of x squared is x equals plus or minus the square root of -4. Well, square root of -1 is I, so this would be 2i. That's not real, so we technically would exclude that from our solution set. Solving x squared equals 1, use the square root method, take the square root of both sides. So we get x is equal to plus or minus the square root of 1, but the square root of 1 is 1. So we have to be careful here. At the beginning of this problem, we had raised both sides to an even power. So we might get what are called extraneous solutions. Answers that don't work aren't really solutions. So we need to go back and let's first try substituting in +1 to see if that is actually going to be a solution. So we have plugging it back into our original equation. We have the fourth root of 4 minus 3 parentheses quantity squared. Is this really equal to parentheses? Now let's drop that 1 in the parentheses, and that's where we saw the x in that equation. Okay, order of operation. So underneath the radical, we want to first simplify that. Exponents come first. 1 squared is just 1, though. Multiplication comes next. 3 times 1 is 3. So we got 4 minus 3 underneath that radical, which is 1. Is that equal to 1? Which it is. If I plugged it in, x equals -1, I actually see that it doesn't work. But, and I forgot this fourth root here. The fourth root of 1 still is 1. It's 1 times 1 times 1 times 1. Multiplying 1 by itself 4 times is 1. Okay. So going back, now looking at -1, we have the fourth root, putting in a parentheses wherever we see an x in the original equation. 4 minus 3, parentheses quantity squared, is this equal to parentheses? Drop in -1. Well, if I square that -1 underneath that radical, that's +1. So I'm actually really getting the same thing that I had gotten before on the other equations. I have the fourth root of 1. Is that equal to -1? And it is not. So we only have one real solution, and that was when x was 1. Any questions on that one? So it looks like we have time for one more. Let me just pull out one more. How about parentheses? Inside the parentheses, you have y in the numerator, all over y minus 1 in the denominator. That is quantity squared. This is equal to 6y all over y minus 1 plus 7. So one more question. We have in parentheses y in the numerator divided by y minus 1. That's all in parentheses, and then that's squared. This is equal to 6y in the numerator. That 6y is all over y minus 1. And then after that fraction, we have plus 7. So I noticed that we can solve this using the method we used at the first day of class, where we cleared our fractions, multiplying by our least common denominator, which in this case would be y minus 1 quantity squared. Or I could use my substitution method again. Let's rewrite it so everything is on one side of the equation, so set equal to 0. So I'm going to just do this. We'll have y all over y minus 1 quantity squared. So I'm going to move the other terms to the other side. So let's subtract 6y over y minus 1. But as I rewrite it, I'm going to write it like this, so maybe it will help you. That's the same thing as negative 6 in parentheses y all over y minus 1. Subtracting 7 to get it to the other side, and now we have it set equal to 0. So factoring out that 6 from the numerator and putting it in front of the fraction shows you that we can manipulate this to be quadratic by letting u equal this y all over y minus 1. Okay, so let's go back in wherever we see that y all over y minus 1, we're going to replace with a u. So we have u squared minus 6 times u minus 7 is equal to 0. I'm happy because I can see that factors really easily. There are two numbers that multiply to negative 7. It would be a negative 7 and a positive 1. So we can factor this as u minus 7 all times u plus 1 equals 0. Looking at that, setting each factor equal to 0, I see u minus 7 is 0 when u is 7. And I see u plus 1 is 0 when u is negative 1. So we'll have two separate equations here. And we're going to solve for y. So we have when is 7 equal to this y all over y minus 1. Well, we have another equation, which is when is negative 1 equal to this y all over y minus 1. So I notice I have an equation, I have a fraction. I'm just going to multiply both sides by my denominator, my least common denominator, which is only one denominator here, y minus 1 on both sides of my equation to clear the fraction. Let's just deal with the one equation first. Nothing cancels on the left-hand side. I notice we can distribute the 7. So we would have 7 times y is 7y, minus 7 times 1 is 7. This is equal to, well, the whole point of multiplying by y minus 1 was so the right-hand side, the denominator would go away, and we're left with just y. So I have a linear equation. I want y's to one side. Let's subtract 7y on both sides. So we would get negative 7 is equal to, well, y minus 7y is negative 6y. Divide through by negative 6. Negative divided by negative is positive, so we get 7/6. Same idea on the other equation. Clear the fraction, multiply by your denominator of y minus 1. Let's distribute our negative 1 to both terms and that y minus 1. So negative 1 times y is negative y. Negative 1 times negative 1, so plus 1 is equal to y minus 1's cancel, y. Y is to one side of the equation, so let's add y to both sides. So you get 1 is equal to y plus y, which is 2y. And then divide by 2 to get y by itself, we get y is equal to 1/2. I do need to be careful. I didn't raise both sides to any even power, but I do have a variable in my denominator. And so you need to make sure that that didn't set the denominator back in our original equation equal to 0. The only one thing that would have done that was if y was 1, so y couldn't be 1. And that wasn't one of my solutions that I got. So our solutions would be 7/6 and 1/2. So hopefully going through those different types of examples was helpful and will help you when you go and attempt or continue to finish that homework. Any questions on that? Any questions at all in general that you want to look at? Technically know who's here today, so I'm not going to take roll because I have a participant thing on the side of my panel. So I'll give you guys all credit for being here. Good sports, thank you for bearing with me today. So if you don't have any questions, you're free to leave, but I am going to be on the same Zoom. I'm not going to actually leave. I do have student hours at 2. So if you have questions and you want to go over particular things from your homework or anything that you're struggling with, come back in like 10 minutes, 13 minutes, and I can help you then. If not, I will see you tomorrow in class at noon. Thank you, everybody. I'll post this video under today. Oh, actually, I'll post this under week 2 module in the in our regular course. And maybe I'll put an announcement where it is so you can find it. But I will post this because I did record while we went through the questions. So I'll post that for you guys to see if you want to go back and look at it. Okay. Have a great day, and if I don't see you in a couple of minutes, in 10 minutes, I'll see you tomorrow. So some of you might be hanging out, some of you might have paused the video or walked away from the room for a little bit. But I am gonna mute my video right here and my audio for 10 minutes and take a break. And maybe I should put that on the screen. Okay, so I'm going to walk away for about 10 minutes and I'll see you if you're here still when I get back.